Hello guys, welcome to the video. In this video, I'm going to explain iris data analysis using Python and some of libraries. I'm going to build an model analysis of iris dataset. Uh, First of all, my name is Pankuma. The main objective of this is to find out the species of a flavor. I take the input as petal length, petal width, and sepal length, sepal width. These are the petals, and this is the length, and this is the width. In the sepal, this is the width, and this is the length. By taking these four inputs, I'm going to segregate the output into these three categories: iris setosa, iris versicolor, iris virginica. By seeing these three peaks, you can observe that the length of petals and sepals are different. By this, we can get the accurate, accurate result of the given input. From after sending this into the model, we get accurate output, which is which one is it is belong to. This project is the part of Oasis Infobyte internship. This is the task one. For this, I collected the data and I imported some of libraries. The useful libraries are pandas, numpy, seaborn, matplotlib, sklearn. Pandas is used to collect the data and read the data to perform some modifications in the data. And numpy is useful to perform mathematical operations on the dataset. Seaborn and matplotlib useful in data visualization. Sklearn is used to help in the building the machine learning models by analyzing. Sklearn provides some tools and algorithms such as classification, regression, clustering, and model evaluation. I'm taking the dataset into df variable using pandas. Df.head will give me top 5 rows and complete columns in the dataset. I have 5 columns in the dataset: ID, sepal and sepal width, petal and petal width, species. Df.shape will give me the how many rows present and how many columns present. In this dataset, 150 rows are present and 6 columns are present. After that, I went to next step, data cleaning. In data cleaning, we we mainly focus on any null values present and we observe data. In data cleaning, df.isNull will give me the true and false of the data. If it is null value present, then it will give me true. If no null value present, it will give me false. Dot sum will give me the entire not present values sum here. Here the sum is 0, so there is no null values present in the data. df.info df.info will give me the column names, non-null value, count, dtype. These are the column names. Total values in the columns. Non-null indicates that there is no null value in the column in the particular cell. If any null value is present, then the number will be changed and it shows non-null. Int float object. Data type. Every column has its own data type. Dtype indicates the type of data present in that column. ID indicates int. It means all the numbers present in the ID. Sepal and sepal width, petal and petal width all contains float values. Float indicates decimal values contained in it. Species is in object. It means categorical data present in the species. Df.describe. This function will describe entire dataset into count, mean, standard deviation, minimum of the data, maximum of the data, and what is the 25th percentage of the value, and 15th percentage of the value, 75 percentage of the value. Df.duplicated.sum gives me the any duplicate rows present in the dataset. It given me 0, so there is no duplicates present in the data. After that, df.columns. This give me as output of all columns present in the dataset. And the datasets, this column names data type is object. It is the data column names are categorical, which means contains letters. So it is object type. ID contains only numerical data, and ID does not add any value to perform any analysis in the upcoming dataset in this dataset. So I am dropping out this dataset, selecting column ID in place to which gives the dataset I'm taking is deleting the ID column is true. It means on next step it will not show me the ID column here. So df.head after running the cell this next step there is no ID column in the dataset. In the 13th step I am getting some output from the species. N unique will give me the number of unique values present in the species column, and df species will give me the unique values in what format. Here we can see the output 3 is the unique number. It means in this species set I have 3 unique names. Those names are Iris setosa, Iris versicolor, Iris virginica, and the data type of this arrays are object, which means categorical, containing alphabets. Next I'm going to perform outliers treatment. Outliers treatment will be performed when the outliers are present in the any column. To check outliers, I mostly prefer df.plot with this plot function is get from the pandas. I given kind box like I need like box format, and this subplots is equal to true, which means I am dividing every block into subplots, every column into subplots. Share a false. Share a will gives that if you need any these y-axis values common for all the columns, then you give share equal to true. If you don't need, you need different columns. For different columns, you need a different y-axis. You can give share is false. Figure size, I given 15 comma 5. The length and breadth of the figure size. From seeing this, by seeing this box plots, we can conclude that some outliers are present in the sepal width. These columns, these circles indicates the presence of outliers in this column. In the remaining columns, all are clear. No need of performing outlier treatment. So for this specific column, I am taking and performing the outlier treatment. For outlier treatment, I am using IQR method. IQR stands for interquartile range. Interquartile range means taking the range. This is 25 percentile. This is median. This is 50 percentile. This is 75 percentile. This is 100 percentile. I am assuming that Q3 in IQR, Q3 means at the 75 percentile, at the 75% the value and 25% of the value, subtracting both of them. By this I can get IQR. I'm finding lower limit and upper limit. For lower limit, I'm taking lower limit as variable and subtracting IQR multiplication of 1.5, which gives me lower limit, and is the same as upper limit. Upper limit variable Q3 means 0.75%. For the 75 percentile, I am adding IQR multiplication of 1.5. It gives me upper limit. In the next step, I am taking the entire column and stating that pd.data from np. We get from numpy, where upper limit above values present in this column. From the upper limit, here we found out upper limit and lower limit. From upper limit, whatever the values present in the above the upper limit, I am taking that in. I am considering that those points are come to upper limit, and where lower limit, below the lower limit, how many points present in the column, I am considering those points in the lower limit. What will happen means this all outliers go to this. By performing this method, after this method, when I plot in the SNS box plot, as same as this plot, I am visualizing plot using Seaborn. PLT.title box plot, it will show me the box plot of the sepal width column. Here we can see 4.0 here. Here we can see 4.0. These outliers are comes to upper limit, that is 4. So there is no outliers present in the column. After this, I am again seeing the any outliers present in the columns. No outliers present in these columns. All are clear. So I'm going to perform no data visualization using SNS.pairplot. I'm taking species as input inside plots, HUA inside plots, and I am using marker as X. This is the pair plot I got for every column with respect to another column by taking x-axis and y-axis all columns. Here we can see that the data is clustered with the same group in different parts in the every graph. We can easily identify that these points are formed in a clusters. Now I am dropping out species column because I'm taking all numeric values and all numeric values in numeric IDs like this, and I'm taking all numeric values correlation. After seeing, I am using Seaborn and using heat map for this. From Seaborn, I am seeing using heat map function correlation matrix. This is the variable I taken here. And annotate 2 means annotations. You need annotations or not? I am giving true. I am giving color map as cool warm. It will be cool warm like this. One indicates there is no relationship. There is a strong relationship between two columns. Strong relationship means there is no any difference in the data. The data is same. We know that sepal length and sepal width of both columns are same. Here we can assume that having correlation 0.6 above is good to analyze, and minus and having correlation 0 means there is no relationship. Having -1 relationship is strongly negatively correlated. There is no relationship between them. I am taking the species count using value counts. Here we can see that there are these species. All these are divided into equal parts. And using pie chart, I am visualizing the same thing. I got 33% distribution in each. Using scatter plot, I am seeing sepal length and versus sepal width. By this data, I am not getting any understanding. So in the next step, I am going to perform sepal length distribution. using species as inset plots to differentiate whether where the output where the data is located, which type of data present. After running the cell, I got this output. Output is like this is setosa and iris versicolor and virginica are somewhat mixed. In the next step, I performed petal length distribution data. I am taking species as in differentiating one. First species setosa here and versicolor here, virginica here. It is linear. We can see that a linear graph is formed in between petal width and petal length. I'm taking species as x axis and y is as columns for all four. I am performing bar plot using Seaborn. I'm performing bar plot on each column. We can see that iris status and versicolor. In the next, I'm going to perform data preprocessing. Data preprocessing is performed before the model building, like changing the data types, converting the data types from. In the past we have seen species categorical data, objective data like iris, setosa, versicolor, and virginica. Here we can see zeros. It indicates that now I am taking the species unique data. By this we can get only three, 0 and 1 and 2. So the three types of data is converted into binary format and allocated one is 0, 1 and 2 D types. After converting this, the data type of species is converted into 32. So my all data is now normal. Normal means all data is converted into binary format. After I go for model building, here I am taking x variable and performing ilog function. Using ilog function, I am taking the 1 to 4. This is ilog is used for indexing 0, 1, 2, 3. These four columns I am taking. This is the columns, and these are rows. We are not specifying any row number here. It indicates that I am taking all rows and four columns. For y, here I am going to take output. These are x is input and y is output. Output of I am taking only species here. Species as output. Species as output in the y variable. Now I am going to split the data using train test split function from sklearn subcategory model selection. I'm taking xtrain, xtest, ytrain, and ytest data and splitting them x comma y, and test size is 0.2. 0.2 indicates that I am dividing the data total data into two parts. One is 80% and another is 20%. 80% will go for test data. Sorry, 80% will go for training the data model, and 20% will go for test data to cross check whether the trained data is giving accurate value or not. For this, I am taking test data. Here I am taking random set as 0. For extrained data, we know that we taken 80% of data, so then we have 120 rows and 4 columns. In extra test, we have only 30 columns, 30 rows and 4 columns. In the white train data, I have 120 rows and 1 column because I'm taken only species column only in the white train. In the white test, I have 30 rows and 1 column. Now I am performing some algorithms on my dataset. From sklearn, I'm already imported the train test data split. I done train test split data. Again, I'm taking here from linear model, I'm importing logistic regression. From metrics, I'm importing confusion matrix, classification report, accuracy score. Here I'm just checking the data, x dot head and y dot head. I'm taking L model. L means logistic model as variable. In logistic, I am taking logistic regression function and max iterate is 1000. We can take any number of iterates, but the after a particular iteration, it will be constant giving the same output. And taking random state as 42. X dot fit. I'm fitting the model in the train and y train. After fitting the data, I'm predicting the here I'm predicting the model. Y predict. In the prediction, I'm taking test data to predict the model. Here we get the model. So after predicting, I am checking the accuracy, confusion matrix, and the report classification report. I am printing the scores for the comparison of training and testing. I get this accuracy one, which is good accuracy, and confusion matrix as this, and classification report is this. We are getting all good values. I'm performing another algorithm on the model, which is random forest classification. Here in a, we use ensemble techniques. From sklearn, we train test in the model building. We perform train test to split data. We divide the data. In here, I am taking random forest classifier and imported metrics from accuracy, classification report, and confusion metrics. This is the data already. We splitted the data. I am taking our model as variable. In the random classification, I am taking an estimate as 100 and random state is 42. Our model dot fit and fitting the model here. I'm fitting the data here and predicting the result of the test score. Comparing the result here, I got the same result as in the past one. In the I am performing another algorithm, which is decision tree. Here we are importing this part. We are importing all. We already imported remaining ones. I am importing a decision tree classifier from sklearn.tree. Here D model decision tree classifier random state is 42. I am fitting the model and predicting the data. This is the comparing the metrics. I got the same metrics as in the past one. I performed the support vector mission. Here I am going to import support vector SVC from SVM. I'm taking S model as variable and SVC, and the kernel is linear. Random state is 42 and C is 1. In the I predicted the data here after training completion. I predicted the data here. Here I am comparing the scores between train and test. I got the same result as in the past. I am performing KNN, K nearest neighbors classification from sklearn only using neighbors. I am importing K neighbor classifier. From metrics, I am importing accuracy classification report confusion matrix. Taking K model as variable and K neighbor classifier as function, and taking N neighbors as is equal to 3. N neighbors means I have only 3 species, right? So I am taking 3. K model fit extrain. I am retaining the data here and testing the data, comparing the data. I got the same score as in the past. Performing naive base classification. I got Gaussian. I am importing Gaussian naive basis from now base from sklearn. N model taking Gaussian NB. I am training the model, fitting the data using fit function. I am training the model. and predicting the model, comparing the scores of train and test. Here I got the same data as in the past, same result I got in the past ones. Total results are in the all algorithms. I got same result as 100%. I'm taking input. Uh, I'm checking the models, all models, and taking the input. Some like randomly, I chosen 2.9, 3.1, and 4.1, 5.2 as my inputs, and taking the input data, predicting the model, the model, n model, k model. These are my variables and predicting the data. After I'm printing the here. Here we can see that all are giving me the same result. So all are giving me 100% true accuracy. Hence all models are working properly. Thank you. My channel name is Data Matters. I value your opinion. I will greatly appreciate your feedback on this video. Feel free to leave your comment and suggestions in the comment section below. Your input helps me improve and create better content. Thank you for watching.